5.2, more with exponents and scientific notation. I'm only going to do the part with the exponents in this video. We will deal with scientific notation in the second half of lesson 5.2. So we have some new properties that we're going to work with here in 5.2 and 5. We will use some of the properties from our lesson in 5.1 and we'll apply them here in 5.2 along with a couple of new rules for exponents. So to start with example A, I have y squared to the fifth power. To simplify this, if I write this out the long way, let's see, it's y squared times y squared times y squared times y squared times y squared. I would write that out 5 times because my exponent is 2y squared to the fifth power. So I'd have to write that up 5 times. Using our property from lesson 5.1, we would add these exponents now. 2 plus 2 plus 2 plus 2 plus 2. That gives us y to the 10th power. Nice, we can write all that out. Is there something that you know how to do with 2 and 5 that gets you to 10? That's right, I can multiply it. So another way that I could actually solve and actually simplify this problem would be if I would take and say, all right, this is equal to y squared to the fifth power is the same as y to the 2 times 5. Or y to the 10th. You can do this problem either way. So this is a rule, a property where it says if I have a power to a power, I can multiply the exponents to find out the correct exponent on my answer instead of writing them out the long way and adding all those numbers together. This rule also can be applied in example B. So here in example B, I have 3x to the fourth to the third power. Written out, it would look like this. 3x to the fourth times 3x to the fourth times 3x to the fourth. Since this is all multiplication, I can reorder this. I can put all the 3's together, and then I can put all the x to the fourths together. So it would be 3 times 3 times 3 times x to the fourth times x to the fourth times x to the fourth. So then when I get my final answer here, I'm going to do 3 times 3 times 3, 27. X to the fourth, if I add those, 4 plus 4 is 8, plus 4 is 12. X to the 12th power. All right, that's writing it out the long way and using our rule from lesson 1 of adding our exponents, and we multiply the numbers. Let's see how if we can apply our example A rule to the example B. In example A, we did 2 times 5 to give us that 10. Let's look here in example B. If I look at just the x piece, I have 4 and 3. My answer has a 12. So on that, yes, we can multiply those two exponents to find the correct exponent on x. The question is, what about the 3? How do I do that? Well, what is the exponent on 3? The exponent is 1. So I can also do 3 times 1. So this problem can also be rewritten as 3 to the 1 times 3 times x to the 4 times 3. And if you look here, I have 3 to the third power and x to the fourth to the third power. Or if I do that multiplying, 3 to the third times x to the 12th. And what is 3 to the third? It is 27. So I say 27x to the 12th. Instead of writing it out this long way, I can distribute this exponent to every single factor on the inside. So I did 1 times 3 and 4 times 3. So 3 cubed times x to the 12th equals 27x to the 12th. You can do it either way. This is how the power to a power rule. C, now I have a negative exponent. A negative exponent then tells us not to be multiplying by 6 to the third, but divide by it. So I want to take, and since that's a negative, I will write this as 1 over 6 to the third power squared. And then I will write 1 over, and if I use my rule from letter A, I can multiply the exponents here. So then this is 6 to the 6th power. And then I have 1 over 46,656. No, I didn't get that off the top of my head. I paused the video and calculated it. I wouldn't expect you to know it off the top of your head. All right, so I have 1 over 46,656. But again, negative exponent means instead of multiplying by this, we're going to divide it. Instead of having this 6 to the 3 on the top, we have it on the bottom as a denominator. So that's power to a power rule when we're doing multiplying. Let's see how we can apply power to a power when there's a division problem, and we'll start here with letter D. If I apply power to a power with a division problem, this 3 cubed, if I write it out the long way, I would write 4m to the 5th over n cubed times 4m to the 5th over n cubed times 4m to the 5th over n cubed. I would write that out 3 times. And then I would then take a look at the top, and I multiply the tops together, and I multiply the bottoms together. So on the top side, I would have 4 times 4 times 4. That would allow me then to say, hey, I could distribute this as an exponent of 1 on the 4, so I do 3 times 1, which is 3. And as I do that, 4 times 4 times 4, that's 64. M to the 5th times m to the 5th times m to the 5th. Well, 5 times 3 is 15, so I have m to the 15th. And then on the bottom, 3 times 3 is 9. So I have 3 plus 3 plus 3 also gives me 9. So in other words, when we have a division problem and that fraction is raised to a power, this power 3 on the outside is done to every single exponent on the inside. In other words, it would look like this. I have it equals 4 to the 1 times 3 times m to the 5 times 3 over n to the 3 times 3. And then I simplify that. 1 times 3 is 3. 4 to the 3rd power is 64. M to the 15th. And n to the 3rd. Or 9th, my apologies. N to the 9th. Both ways work. But again, power to a power, even though there's a fraction or a division problem in here, we will distribute that 3 to every single exponent on the inside, and then we'll simplify. How does that apply then, like in letter E, where I have a negative exponent? Remember, negative says, it would say 1 over all of this. Well, 1 over a fraction seems a little complicated. So what is the next thing that tells us? First thing before we try to do any of that is we will apply the power to a power rule, and we will multiply the negative 3 times the exponents. So when I look at letter E here, I'm going to say, okay, I have negative 3 times negative 3, so that is 2 to the 9th power. Nice, my negative disappears. Over y to the negative 6. All right, so what do we do now? I got a negative in my denominator. Let's simplify the top first. 2 to the 9th power. 2 to the 9th power. 2 to the 9th, that's 512. And that's over y to the negative 6. So what do I do with this negative 6? What do I do with that? Well, let's see. This says, since it's dividing, use the reciprocal of that or the inverse of that. And I'm going to place this y to the negative 6 is dividing, but it says a negative exponent. So instead of having it on the bottom, I will change it. And I will move it up with the 512. It means put it in its reciprocal location. Instead of dividing by that, multiply by it. So when you see that negative, it means use the inverse. If it's showing multiplication, show it as change it to division. If it's showing division, change it to being multiplied, like I did here. So the final answer here is 512 y to the 6th. It was in the denominator with a negative. I move it to the numerator. So this would be like y to the 6th over 1. But I'm going to leave it this way. I don't have to write this as dividing by 1. Letter F. Letter F. And we're getting there. All right, so letter F. I don't have any parentheses out here, but I have numbers. I have 6 to the negative 2, but a no number underneath. Since this is currently in the numerator, put it in its reciprocal location, and instead of in the numerator, I will put it in the denominator. So I'm going to make a fraction bar here. That means I'm going to put 6 squared in the denominator. Now I have x to the negative 4 divided by x squared. Subtract your exponents. That rule applies from lesson 5.1. Negative 4 minus 2, negative 6. So I have x to the negative 6. Excuse me. So now I have I have 6 squared on the bottom, and I have x to the negative 6. So that would be sitting here, wouldn't it? And then I have the y part. I have y to the 10th over y to the negative 6. 10 minus negative 6. 10 minus negative 6. 10 minus negative 6. 10 minus... mess, Mr. 10 minus negative 6. Same, change, so it's 16. I have y to the 16th, don't I? Y to the 16th. So the question now is, what do I do with all of this? How do I write this? Well, let's see. And on the top, to start with the x, I came out as x to the negative 6. So that means I'm going to put that in its reciprocal location. And oops, my fault. Let me start back over on this. I have 6 squared on the bottom. 6 squared is 36, so I have a 36 on the bottom. I currently have an x to the negative 6th when I did this here. That means x to the 6th is in the denominator. Y to the 16th, it's positive, leave it up there. So I have y to the 16th. And then I'm finished. There's nothing else to simplify, add or subtract, or raise power to a power. This final answer is y to the 16th over 36x to the 16th. So let's review. And I'll try to write this out just a little bit of a different way for you. So on the just again, very briefly, 6 to the negative 2, that's 1 over 6 squared. I'm going to break this part into 3 pieces for you. So 1 over 6 squared. I'm going to go like this. I'm going to break that apart like here and here. Negative 4 minus 2. And as we found, that's negative 6. So this is times x to the negative 6. Times 10 minus negative 6, that's still 16. Y to the 16th. Now looking at this here, I have 1 over 6 squared. So that's 1 over 36. X to the negative 6 is 1 over x to the 6th. And y to the 16th is still just y to the 16th. So that's like over 1. Now when I multiply all this together, I will get y to the 16th on the top. And on the bottom, I have 36x to the 6th. And there's my answer, same answers I got before. Hope that second explanation clears some things up. I felt as I went through the first one, I might have been confusing some of you, but I hope this second one clears it up. Third, G, go back, go. All right, here we go. Now I have a negative exponent on the outside. Still distribute that to every single factor on the inside, like we showed you power of the power in an earlier example. So now I have 4 to the negative 2. And then I have negative 2 times 3. So it's a to the negative 6. And then negative 2 times 2, b to the negative 4. On the bottom, I have negative 6 times 2, draw my fraction bar, b to the positive 12. And then I have a good old-fashioned c to the negative 2. All right, now notice when I did this, I lined up the b's. There's nothing above c because the top doesn't have a term with a c in it. There's nothing on the bottom with an a and nothing on the bottom with a 4. So now let's break this apart. 4 to the negative 2, that's 1 over 4 squared. The next one I have a to the negative 6, so that's 1 over a to the 6th. The next one I have b to the negative 4, over b to the 12th. Negative 4 minus 12. Negative 4, a little scratch paper here. Negative 4 minus 12. Same, change, change. Negative 16. So now then I have b to the negative 16. And lastly, I have c to the 1 over c to the negative 2. So now we're going to try and get an answer here. Fraction bar, looks like I'm in a fraction. 1 over 4 squared. So 4 squared is 16. That will stay in the denominator. 1 over c to the 6th, or a to the 6th, I'm sorry. A to the 6th, that will stay in the denominator. I have b to the negative 16. So that's like b to the negative 16 over 1. That means put it in its reciprocal location. So instead of being multiplying on the top, it's going to do some division from the bottom, and I'm going to have b to the 16 on the bottom. And over here, I have 1 over c to the negative 2. That means put this, instead of dividing by c squared, you need to show that multiplying on the top by c squared. So I'm finished. I have c squared over 16, a to the 6th, b to the 16th. All right, final answer there. So now we're all done with the examples. Here's the rules we went through. Rule 1 that we showed you back in examples A and C, a number raised to a power, we can multiply the exponents. Rule 2 is if I have two factors inside, or two numbers inside of parentheses, I will distribute that power to both of the factors. So I'd have a to the m power, b to the m power. And that was example B, is where the first time I showed you that. We used that throughout all the division ones also, especially like up here in example C, you can see where I used that. And the third rule I was showing you is that if there is a fraction raised to a power, that power is used and distributed to both exponents on the numerator and the denominator. And this was in examples D, E, and G. All right, so now that is the end of this video. Reached a little longer than I wanted it to, but in case you're wanting to get started on the assignment before you come into school, here it is right here. It's page 269, numbers 3, 6, 7, 10, 12, 19, 23 to 27, 47, 50, 51, 53, 55, and 56. Let me know what I can help you with. Thanks.